So, two structures of covalent substances then. The first one is covalent molecules. Now this is another note I'd like you to take. It has a wee pencil on the top right hand side of the slide. That's how you know you have to take it as a note. Covalent molecules can be solids, liquids or gases at room temperature. They have low melting and boiling points. Some examples I've given you are CO2, so carbon dioxide, SO2, sulfur dioxide, and water. Now you can see their kind of structures over at the side here. These exist as discrete molecules. They have very, very low melting and boiling points. That's how we identify them as molecules, because the other structures are giant covalent networks. Now they are a bit different in that they have extremely high melting and boiling points, which means they're always solids at room temperature. Now this is why you can find covalent molecules as solids, liquids or gases. They have low melting and boiling points. So some of their melting and boiling points might melt at -10, they might melt at 0 degrees Celsius like water does, and boil at 30, 40, 50 degrees. Now that means that they can be solids, liquids or gases around any of those temperatures. Covalent networks, we're talking thousands of degrees Celsius to even melt those from a solid to a liquid. So that is a big, massive difference. So covalent molecules, you have some examples. They have low melting and boiling points and they are found as solids, liquids or gases. Covalent networks are the opposite. They have extremely high melting and boiling points, which means they are always solids at room temperatures. And the examples you have are diamond. Now, diamond is a structure of carbon, which is in a giant covalent network. And you have silicon dioxide as well, which is sand. A wee bit about that later. But those are the examples. You should always kind of choose one covalent molecule example and one covalent network example that you know a few different things about. You can maybe draw the structure, just so that if you were ever asked, for example, an open-ended question, you would have an example of each to include in your answer. A little task for you then. There are some compounds on the slide. I'll send these slides out for everybody like I always do. You have some examples of compounds at the bottom, and all you have to do is sort the list into conductors and non-conductors. So we've learned so far that covalent compounds never conduct. So what you're going to have to do here is you're going to have to look at the compounds very carefully and decide, is this an ionic or is it a covalent compound? If it's an ionic compound, you have to remember your rules for conductivity. If it's molten or aqueous, it will conduct. If it's solid, it won't. And if it's a covalent compound, it never conducts. So I would like you to do that in your jotters, please. Upload a photo and you get 10 marks or 10 possible marks for correct answers. So the question that we want to ask ourselves is, why do covalent molecules have such low melting and boiling points and covalent networks don't? They are all covalent things.